Hey everyone, and welcome back. In this next video, we are going to finish filling in the unit circle. So as you can see, we have the coordinates filled in, and we also have the degrees, but we have a few more blank spots to be filled in throughout the unit circle. So what is going to go in that spot? And I'm here to tell you that there's two ways we can measure angles. The first being the conventional degree measure that we know and makes sense to us, but there's also something called a radian that we are going to use, and they're equivalent, right? They're equivalent, they're exactly the same, just represented in a different way of those angle measures. So let's hop into it and let's discuss radians. So what is a radian? A radian is a unit of an angle where the arc length is equal to the length of a radius. I'm going to draw your guys' attention to the photo on the left, right? Arc length, that means the side of this circle right here. This arc length, 1 radian is where that arc length is equal to the radius of the circle. So that's what 1 radian is. And in the unit circle, radians are measured using increments of pi, where pi is 3.14, 1592653, ... right? So a radian is where the arc length is equal to that radius length. And we know on the unit circle that our unit circle kind of looks like this, right? Right? So for this 30-degree measure right there, our arc length, that angle, instead of it being 30 degrees, can be measured by a certain number of radians, where this arc length is equal to this radius right here. And basically, to put it in layman's terms a little bit, is essentially we can think of this as the crust on our unit circle pizza. Okay, we can think of the pieces of pizza as being our angle measures, right? Or our degrees, if we were using degrees. And then also our radian is then just going to be the length of the crust for that particular piece of pizza. So radians are just like the crust. They're measuring the outside of the circle and how many pieces of pizza, how many crust pieces goes all the way around our unit circle is what we're going to use to determine what is called a radian. So a radian really is just the perimeter, the outside of our circle, dependent upon how large the angle is, how big that piece is that we're looking at here. So it really kind of all ties back into circumference, right? Because essentially, like the outside, the crust of a pizza, like I was just saying, the crust, the outside is essentially going to measure the circumference, right? So the circumference of a circle is what a radian is, and then we're just breaking it into pieces, just like we broke degrees into pieces. So my question for you is, what is the circumference of a circle if the radius of that circle, is 1? And in case you didn't remember, there is the circumference equation. Circumference is equal to 2 pi times the radius. What is the circumference of a circle with a radius of 1 unit? Exactly. Circumference is 2 pi times 1. So the circumference of a whole circle is 2 pi, right? Working through our unit circle. So the entire circumference is 2 pi radians then. My unit circle pizza has 2 pi radians from start to finish. And if 2 pi is one entire rotation around, how many is in half of a circle? What is, if 2 pi is the circumference of a whole circle, How many radians, what is the circumference of a half a circle? That would be 2 pi divided by 2, or just simply put pi. So halfway into my radian pizza, I'm going to have pi. The circumference of that is pi, right? Remembering that radians is just this arc length, right? So in half of a circle, it's pi radians. In a whole circle, we have 2 pi radians. And basically, we're going to use this to break down the radian measures of our unit circle. So we kind of started to answer this already. We said that in a unit circle, we are going to have 2 pi, oops. In one whole circle, there are going to be 2 pi radians, right? So finishing, start to finish of my entire arc length, right? All the way around the arc length of this entire unit circle, start to finish, that is going to be 2 pi radians. And if I just start without making any rotations then, right? If I just start right here, I never make the actual distance, then that's going to be 0 pi radians. So I'm just going to fill out in 0 pi as the start. And once we actually complete the entire unit circle, that is 2 pi radians. Again, in half of a circle, that's 2 pi divided by 2. So that's going to give us our pi radians in half of our unit circle. And then we can kind of start to break it up into pieces again. We can see that, okay, well, half of a circle is pi. What about if I broke my unit circle into quarters again, right? If pi is half, what is half of pi? How can I determine what a quarter of that circle is? That means I'm going to take pi and divide that guy by 4. So that really just gives me pi over 4 radians. I'm sorry. Excuse me. Psych, right? If half of a circle is pi, half of that gives us pi over 2. So in a quarter of a circle, I apologize, quarter of a circle, we're going to have pi over 2. And the reason I did that, I just determined that I was taking half of this. Half of this gives us pi over 2 radians. My apologies. Mistakes happen. Okay, so if that is 1 pi over 2, kind of like we were thinking of the rotations with degrees, right? So now a quarter of my radian pizza, the circumference, the surface, the arc length of a quarter of my pizza is pi over 2. A second quarter of my pizza is 2 pi over 2, right? 2 pi over 2, and that just reduces to pi. So we're back where we started at pi radians. And then if I go another quarter, then that's going to be 3 pi over 2. 3 pi over 2. And finishing the circumference, I'm going to end up at 4 pi over 2 radians, 4 pi over 2, which again reduces to 2 pi, which we already had. So now that we've broken things into quarters, we're going to continue to break our circle down into pieces, just like we did with the degrees. It's just now we're working in increments of pi, starting with 0 to 2 pi. We broke that in half to get pi, broke that in half to get pi over 2. So now we're going to continue breaking things in half and talk about, all right, well, if pi over 2 is up here, what is half of pi over 2 to get this measure? What is half of pi over 2 to get that measure? So I'm really taking pi over 2 and I'm going to divide that by 2. I'm going to divide that by 2 to get that next radian measure, and that gives us pi over 4. Okay, so this radian measure right here for this green one, in between 0 and pi over 2, that arc length then is going to be pi over 4. Pi over 4. So remember, the radian measure is really just the arc length. So this piece right here is 1 pi over 4. And if I continued, then I'm going to have 2 pi over 4, which is pi over 2. And then I'm going to have 3 pi over 4. Pi over 4. Continuing on, I add on another pi over 4. That gives me 4 pi over 4, which reduces to pi. Then I end up with 5 pi over 4. Continuing, I end up with 6 pi over 4, which is 3 pi over 2. 7 pi over 4. And finishing, ending up at 8 pi over 4. 8 pi over 4 reduces to 2 pi. So we're almost done. We are super close, almost done. So we are going to continue breaking down our unit circle in radians by thinking of cutting these things into fractions. The next way we're going to do is just like we did with the degrees, where we cut the pi over 2 into 3 equal pieces. Okay, so basically we've worked around the unit circle, cutting it into pieces and measuring that arc length, and that's what gives us a radian. So now we're going to go back and focus on quadrant 1. We can see that quarter of our circle is pi over 2 radians, and we want to break that quarter into 3 pieces. I want to break it into this chunk right here and this chunk right here. So really what I'm asking myself is, how can I break pi over 2, that first quarter, into 3 pieces? So what is pi over 2 divided by 3? And pi over 2 divided by 3 gives us pi over 6. So each of those increments is pi over 6 radians. And since we like to work counterclockwise with our unit circle, then from here to here is going to be pi over 6 radians. Okay, and we're just going to count just like we had been. We're just going to count in increments of pi over 6. So this arc length right here, that first arc length, is 1 pi over 6. The next arc length is going to be from here to here. That's going to give us 2 pi over 6. But notice that 2 pi over 6 can be reduced, which really gives us pi over 3. Then we just keep counting in increments of pi over 6. The next one would be 3 pi over 6. And what do you know? Visually, that's this piece right here. And 3 pi over 6 also can be broken down. 3 pi over 6 is pi over 2. And we already have that on our unit circle. So continuing to count in increments of pi over 6, now we're going to be at 4 pi over 6. 4 pi over 6 does reduce though. 4 pi over 6 gives us 2 pi over 3, just dividing the numerator and denominator by 2. So our next radian measure is 2 pi over 3. And again, that's measuring this arc length from here to here. So I'm breaking things into thirds now. So from pi over 2 to the next one is 3 pi or 2 pi over 3. The next arc length is going to be 5 pi over 6, adding on 5 pi over 6, which does not reduce. So this measure is 5 pi over 6. Continuing on, I end up with 6 pi over 6. And what do you know? That just reduces to pi. And we already have pi. That's this radian measure, that arc length. Then continuing on with the pattern, we just keep adding on 1 pi over 6 each time. So 6 pi over 6 plus 1 more gives us the 7 pi over 6. The next arc length is going to be 8 pi over 6, but that reduces to 4 pi over 3. This arc length. The next one is going to be 9 pi over 6. Which reduces to 3 pi over 2, which we already have in pink. And we just continue on this pattern for quadrant number 4. So 9 pi over 6, adding 1, that's going to give us 10 pi over 6. But we can see 10 pi over 6 is going to reduce. 10 pi over 6 is going to give us 5 pi over 3. So that arc length is going to be 5 pi divided by 3. That was 10 pi over 6. And then there's only one more pi over 6 to count, 11 pi over 6. That does not reduce, so our radian measure is 11 pi divided by 6. And to make things come full circle, we would have 12 pi over 6, which is 2 pi. So all of our radian measures have been filled in now. So just to recap, to get all of the black radian measures, all of the arc lengths splitting the first quarter into thirds, we ended up with pi over 6 radians. And we just went throughout the entire unit circle, starting at 0, and counted out increments of pi over 6. You can see all of that information put on the left. So 1 pi over 6, 2 pi over 6, 3 pi over 6, all the way to 12 pi over 6. So as we counted by pi over 6s, we basically realized that if they were able to be reducible, they're reducible fractions, we got different values. So 2 pi over 6 becomes this brand new value pi over 3. 3 pi over 6, we already had pi over 2. 4 pi over 6 becomes 2 pi over 3. 5 pi over 6 stays. 6 pi over 6 is just pi. 7 pi over 6 stays. 8 pi over 6 is a new increment, 4 pi over 3. 9 pi over 6 is 3 pi over 2. We already had that. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 stays, and 12 pi over 6 reduces to 2 pi. So we can see that although we're really counting by pi over 6s, some of them are new and some of them are old. The quadrantal points remained the same. Those were the pi over 2, pi 3, pi over 2, 2 pi's, but all in all, we essentially are just counting by pi over 6s. So 1 pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. We have filled in the entire unit circle. You also are going to need to memorize these angle measures. Remember that a radian is just the circumference of that same angle measure. It's the same thing. Pi over 6 is equivalent to 30 degrees. It's just in a radian measure. So take a second. Let me know, what patterns do you notice? And how do these relate to the degree measures found earlier as we worked through the unit circle in degrees? In our next video, we're going to talk about how to convert between degrees and radians, which is really quickly, a pretty quick conversion. And I'll see you then.